Good morning everyone. Myself Sandeep Kumar Sahu. Welcome back to our online class of iron making. In our last class, we have discussed about the raw material of blast furnace, that is the iron ore. Today, we will discuss about the other raw materials, importantly the coke and the flux. These are the outlines of today's lecture. Those are coke and its importance, coal reserves, world and India, coke making technologies, testing of coke, coke rate, flux for blast furnace, and finally the concluding remarks. First of all, what is coke? Coke is the carbonation product of metallurgical coal. Carbonation product means the destructive distillation process. Though it is expensive, but coke is inevitable for blast furnace iron making. It accounts for almost 50% of the cost of production of hot metal in a blast furnace. It can be seen from the figure that about 45 to 50% of the cost of the production of hot metal is coke, and less all other processes, all other requirements are within 50%. So why it is so expensive? Especially in India, it is more expensive. We will have some idea about this when we know about the different raw materials of different deposits of coal mines in India later on, and why it is so important for our iron making. Why coke is so important? If we look at the functions of coke inside a blast furnace, then we can judge its importance in our iron making, blast furnace iron making. What are the functions? First, as a fuel, it provides heat for endothermic reactions inside a blast furnace and also for melting of slag and metal. Secondly, provides reductants. That means coke produces and regenerates, reducing gases for reduction of iron oxides inside a blast furnace. Reductants. And what is special? Coke provides an open permeable bed through which reducing gases pass upward and slag metal trickle down through this permeable bed to the hearth of the blast furnace. Besides this, carbon of coke is responsible for lowering the melting point of iron by carburizing it. It can be easily known from the iron carbon diagram, as it is every parametrical route requires to lower the operating temperature of a furnace. All the above functions above the third function, that is the spacer, can be substituted by coke as a raw metal inside a blast furnace, but the point 3 cannot be replaced. The function of coke cannot be substituted by a coke because by a coal, because coke has certain properties like strength, hardness, and porosity, which a coal doesn't have, to replace it inside a blast furnace. So at least some amount of coke is required inside a blast furnace, in every blast furnace, to make it operative. It may be nearly about 300 kg per ton at minimum for a furnace. Then we look after the coal reserves all over the world and India. The total coking coal reserve of the world exceeds 1 trillion tons, out of which only the half of the amount of coal is suitable for coke making. The major producers are USA 23%, Russia, that is also 23%, and next China is 11%. If we discuss about the Indian scenario, Indian coal reserves, then about total coal reserve is about 200 billion tons, out of which only 30 billion ton, that means on the 14 to 15% are coking coals. It shows coking coal is scarce in India. Further, this limited amount also suffers from ash problem. That means it contains about up to 30% ash. So quality of this coal is also poor. Along with poor washability of these Indian coals leads to limited yield up to 55% for removing only one third of the ash. So the process makes it more and more expensive. As we have only 3% prime coking coals, 3% only, prime coking coals only 3%, we have to improve the blast furnace operation with the help of this good quality of coke by importing the coke from abroad, especially from Australia, and we have to blend them with Indian cokes, and all these processes makes the coke expensive one. From Indian scenario, the coal deposits are total 246 billion tons, proven 90 billion tons, indicated 110 billion tons, and inferred about 46 billion tons. Among the states, it is the I think that is the Jharkhand, Chhattisgarh, that is proven 9 and indicated 25, total 34, and in case of Jharkhand that is proven 35 and indicated 30 and total 65, and in Odisha there are proven 14, indicated 30 and total 44. So generally these three states are abundantly available, coal is abundantly available in these three states, but the quality of coal is not up to the mark. Then the coke making technologies. So as we know that steel, iron and steel making are very old technologies. So old practices of coke making is the behave oven process. From the top, we add generally the coal to the behave oven, and also we ignite from the top. From the bottom side door, the coke is extracted when it is the cooking process is over. Very limited air is supplied, so limited air restricts the combustion of this coke inside a beef oven. The total gas escapes to the atmosphere through the top hole. So all the gases will release and join the atmosphere. So it will pollute the atmosphere. So nowadays this is no longer applicable. Another method, the conventional method, which is called your byproduct coke oven process. In this process, in this plant, several narrow vertical and rectangular coke ovens are connected in series. That's why it is called coke oven battery. Series of coke ovens. Heat is supplied from the either side of the oven through heat chambers. As shown in the figure, uh, after the side wall there is heat chamber from which the heat is supplied to the uh, coal to produce coke. Okay, and the fuel is burnt inside the fuel chamber, and the solid coke, both gas and liquid, are recovered as byproducts. So it is called your byproduct coke oven process. Okay. So if we look at the productivity or the output of a conventional byproduct coke oven process, so about 750 to 800 kg of coke is obtained. Okay, 45 to 90 kg of coke breeze is obtained. That means the fines. And coke oven gas, which is a very good fuel inside the steel plant, that is 285 to 345 meter cube. 27 to 34 liters of tar, 55 to 135 ammonia liquor, and 8 to 25 liters of light oil. So this makes the process more revenue generating. And uh, as the stringent as the stringent guidelines have been placed before us, so we have to go for less amount of pollution or emission from these coke oven plants. So the recent technology for cooking process is your non-recovery coke oven process. Here, the as the byproduct coke oven pollutes the atmosphere, large capital investment is required to make the such ovens capable of fulfilling the stringent environmental norms. So we have to depend upon non-recovery coke oven plants. In non-recovery coke oven plants, the coke oven gas is completely burnt inside the chamber. Okay, heating is bidirectional mode, but here in case of conventional byproduct coke oven, here it was lateral movement, lateral heating, but here from top and bottom the heat goes from both the directions, from top to bottom in case of non-recovery. Okay, more land space is required as the height of the bed we cannot increase much more high, but it doesn't pollute the atmosphere because it doesn't go for any byproduct recovery plant, or all the byproducts are burned inside the blast furnace, sorry, in the coke oven, so it doesn't pollute the atmosphere. So it also leads to less revenue generation. That means revenue wise it is less attractive, but some amount of coke burns which we cannot avoid. So unavoidable coke burning inside the coke oven plant takes place, so its productivity will be less than that of the byproduct coke oven plant. Another very innovative coke making process is called the stamp charging process. Stamp charging. Stamp charging means what? It provides the scope for compromising the coal quality. Means low quality coal can be used, but without compromising the quality of the coke. How can it be done? So in this process, the cooking and non-cooking coals are blended. A cake is made. That means it's compressed and compacted outside the coke oven plant into a stable briquette to increase the bulk density about 30 to 35% increasing. The briquette dimension is almost same as that of the chamber of the coke oven plant, or coke oven plant, yes. Then it is pushed into the coke oven. As the bulk density of the coal has been increased, the coke formed will be much more stronger. This technique provides the scope for compromising the coal quality. That means utilizing to some extent of non-coking coals. But stamp charging improves the quality of the coke about 10 to 12%. Productivity will be increased by this stamp charging inside the coke oven plants. The next, so we have got our coke oven plants which produces our coke, but let's discuss the properties which are required for a coke to be used as a blast furnace fuel or raw material. Coke suitable for blast furnace should be sufficiently strong to resist the shatter during the handling prior to charging. That means it is during the charging and raw material handling, so it should have much more higher strength, so that fine generation will be less. It should be able to withstand the pressure exerted by the overlaying burden. So because huge tall blast furnace, so much amount of burden is there, so coke has to withstand all the burden because it is the solid material till the 2 years level before burning. So it has to withstand all the pressure, and also it has to be reactive enough to produce carbon monoxide as it descent from the top to bottom, because reduction is required. So it should be reactive enough to produce carbon monoxide, and also strong enough after reaction to ensure permeability in region below the cohesive zone, because at the cohesive zone the strength of the all other raw materials are very less because they have been fused. So coke is only the raw material which is not which has not been fused. It is only responsible for the bed permeability, so it should have enough strength to maintain the bed permeability to make the reduction feasible. Therefore, coke reactivity and its strength both at room temperature and at elevated temperatures are necessary to be accessed for its suitability. So for room temperature strength, we generally go for Micom index test or Micom index. In this test, about 50 kg coke sample of 50 to 60 size taken in a mild steel drum, which is rotated for 4 minutes with a RPM of 25. Then it is screened and screened with 60, 40 and 20, 60, 40, 20 and also 10 screens. The percentage mass coke retained on 40 screen is called M40, and those passes through 10 screen are called M10. And the M40 indicates the resistance of the coke to breakage by impact, and M10 shows the resistance of the coke to abrasion inside a blast furnace. Okay. So when we talk about high temperature characteristics, the the coke reactivity, which is most important parameter. What is reactive coke reactivity? It measures the rate at which the coke carbon reacts with the oxidizing gases like carbon dioxide, oxygen, air, or steam. Okay. The Japanese method developed by Nippon Steel Corporation is generally universally accepted for testing of this coke reactivity index. In this test, generally 200 gram of coke of 20 size is exposed to a stream of carbon dioxide with a flow rate of 5 liters per minute in a tube furnace at about 1100 degrees centigrade for a particular time, that is about 2 hours. The residue after this reaction or after 2 hours is cooled and weighed, and this indicates your CRI, coke reactivity index. That means the original weight minus the weight of residue divided by original weight into 100. This is called your CRI, coke reactivity index. The residue is tested for its strength by tumbling in an eye drum with 130 diameter and 170 length, which is rotated at 20 rpm for 30 minutes. The coke strength after reduction is measured as CSR, coke strength after reduction, weight of plus 10 coke after tumbling divided by initial weight of the coke into 100. Okay, these two parameters CRI and CSR are independent, but it is agreed that coke having high CRI value generally has low CSR. So which has high CRI value generally has a low CSR. Okay, as per Rent et al., here is a correlation between CSR and CRI of different cokes, which is shown in a figure. The x-axis is your CRI and y-axis is your CSR. So the data shows that the slope is downward. So when the CSR increases, CRI decreases, or vice versa. Next, what is coke rate? Coke rate means amount of coke required for production of 1 ton of pig iron. As we know that the 1 ton of pig iron is a basis. That means the kg of coke required to produce 1 ton pig iron. Okay. So it includes, this coke rate includes carbon utilized in carburization of iron. That means to decrease the melting point, that is the CC, to carburize the iron, plus the 2-year carbon, that means the amount of carbon burned to produce heat and carbon monoxide, that is the 2-year carbon, and direct reduction carbon for direct reduction of iron oxides, direct reduction of iron oxide at the bottom of the blast furnace, along with direct reduction of carbon for the direct reduction of metalloids, direct reduction of carbon that is needed for the metalloids to be reduced. Okay, so combiningly it forms the coke rate. Okay, so we can relate the coke rate with the blast furnace productivity, that is the P equal to Q by K, where Q is what? Q is the coke burnt per day, which is also called a coke throughput. How much amount of coke is burnt per day? And what is K? K is coke consumed per ton of hot metal. Okay, K is the coke rate. Okay, so reduced coke rate also increases the productivity. So we have to reduce the coke rate because coke rate at the denominator. So if we decrease the coke rate, then it will increase the productivity. Okay, so how can we decrease the coke rate? So this can be achieved by several methods like increasing the blast temperature in the stove. Okay, proper burn preparation before charging, some blast additives that may be solid, liquid, gas, solid like pulverized coal, fuel oil, steam, etc. Blast additives. Okay, and applying high top pressure. The top pressure, if increased, then it will also helpful for your less coke consumption. And these, all these we will discuss in our modern trends in blast furnace later on. Okay. And another point is that firm coke. What is firm coke? It has been proven to be a good alternative to the expensive coke. Okay. So a new method for making the coke of blast furnace under consideration. Okay. It includes crushing of low caking coals and pelletizing them into the desired shape and coating with hematite or lime powder prior to carbonizing in a normal coke oven. Okay. Experimentally, it has been proven to be a good alternative. Okay. Experimentally, it has been proved, and the pilot scale it has been also be proved. Okay. So it will be a potential material for a blast furnace iron making. Then the another raw material, that is your flux. What is flux? So we know that slag is produced with gangue and flux. Slag equal to gangue plus flux. The slag means it is the molten oxide byproduct of any regular uh, conventional smelting process. Okay. So and the gangue comes from anything. That means your ore contains high amount of gangue also. Coke has some ash which has silica, alumina, all these things which joins the gangue, and also flux itself contains some amount of gangue material. If you go for any type of flux, it may contain SiO2 or Al2O3, anything that may be treated as gangue. So what is the role of flux? Flux brings down the melting point of gangue so that the fluidity of slag will be increased. Okay, and also it maintains the basicity of slag. What is basicity? Basicity means it is the ratio of all the basic oxide to all the acid oxides. Okay, So due to flux it is maintained. Okay. Mainly used flux inside a blast furnace are limestone and dolomites. Okay. So lime and also the magnesia content in a flux decides the quality of your flux. Okay. Generally, the flux are evaluated. How these flux are evaluated? On the basis of available base. What is available base? Available base means in a simplified equation, we can say that summation of all basic oxides minus acid oxide into B. That means what amount of acid oxide is contained in the flux itself, that has to be multiplied with the basicity, required basicity of the slag, and has to be deducted from the basic oxide, so that this is the available base for your reaction. So it is the process of evaluating a flux. Generally, in a normal blast furnace, the basicity is maintained above 1, that is 1.02, 1.3, 1.4. Okay. So we'll discuss about the slag in uh, next classes. Okay. So then we'll talk about this acid oxide and basic oxides. So concluding this class, what we know in this class, coke is a very important raw material for blast furnace, which accounts for about 50% of the total cost of production of hot metal. So 50%, the lion's share is taken by this coke. So we have to look after the alternatives of coke. Okay. Non-recovery coke oven does not pollute and has an age to survive in future. But it is not advantageous for revenue generation. Okay. As all the byproducts are burnt inside the coke oven, so it is not as much as advantageous for revenue generation as in case of conventional recovery coke oven byproduct recovery coke oven plants. Okay, stamp charging offers an unique opportunity of blending low grade coal with good coal without compromising the coke quality. So as we have seen the reserves of coal in all over the world, especially in India, so we have to think about non-coking coals for utilizing in the blast furnace. Okay. Coke reactivity and its strength both at room temperature and elevated temperature are necessary to be accessed for its suitability. Yes, so as we know that the coke is the backbone of our iron making process, so it should have the adequate quality to operate the blast furnace smoothly. Coke rate influences the productivity of blast furnace because lower the coke rate, higher the productivity. Firm coke can be a good alternative to the coke. Okay, flux can be evaluated on the basis of available base. Okay, so from this class we have studied all these things. Okay, if anyone have any doubt, they can ask. Thank you.